All right. Next we have on stage Anshul Sharma. So he's going to talk about Project Flogo as ultra-wide Internet of Things apps framework. So the topic is connecting the edge.
Okay, thank you. Hello, everyone. My name is Anshul Sharma. I work as a solutions architect at Chipco. I've come here all the way from India to speak at FOSDEM. So before we start, right, I just want to ask, how many of you have built apps for IoT devices or played around with your home automation with Raspberry Pis or Arduinos? Okay, great, quite a few. So as you all know, right, most of these devices do not have the luxury of huge computing power at their disposal. They are usually equipped with very few MB of RAM, and in some cases, it's as low as few KBs. So what I'm going to talk today in my talk, Connecting the Edge, is like how Project Flogo solves this problem and provides you, enables you by providing a rich framework for building IoT apps. So let's get started. So this is how the connectivity looks like, right? Everything right from your refrigerator, televisions, your cars, everything is getting connected to the internet. So in 2015 itself, there were around 4.9 billion devices which were connected to internet. And the estimate is around by 2020, there will be like whopping 50 billion devices, connected things, which will be connected to the net. The problem with this is like we need to make sure like the technology challenge, like how do we connect these devices? But on the upside, it's a huge market potential of 10 to 15 trillion dollars that is waiting for us to get, for the developers to harness. So what are the typical IoT use cases that we are seeing right now, right? We'll just see a couple of them. Industries are facing huge losses when their equipments are malfunctioning or breaking down. So with IoT coming into picture, these devices or the machineries are getting smart enough, they are predicting enough, like based on the data, like when they are wearing out, when do they need maintenance, pre-hand, so that we can plan the downtime accordingly. The another prominent use case is connected cars, right? The cars are not only providing us with directional or navigational information, but in the future, based on your driving patterns and your habits, based on the real-time traffic conditions, weather conditions, it will also predict what is the probability of you getting into an accident and provide you useful insights. Another popular use case is around smart meters, wherein you can track your consumption of resources of electricity and water in real time, and the system can provide you insights how you can save some money by adopting good habits. So the architecture of today as we speak is very much cloud-centric. Centralized architecture. All the devices are sending the data to the cloud, all the heavy lifting happens in the cloud, and the results are sent back to the devices. The processing is almost completely happening centralized in a one location, that is your cloud. There's an urgent need that we embrace edge computing. Why do I say that? A connected car produces approximately 5 terabytes of data every hour. An oil rig produces 5 to 7 terabytes of data every hour. Imagine this, like such huge data, if you send it to the cloud, process, act, and send the results back, that might be too late. That is no more real time. So what we need is, like cloud-centric IoT is not reliable in this particular case. So we need to move our computing and analytics to the edge. That is the point of action wherein all the collection of data is happening. Okay, so how do you do that? How do you embrace edge? So the answer for that is Project Flogo. So what is it exactly? It is an ultra-light edge microservices framework. When I say it's ultra-light, it's 50 times smaller in footprint compared to Java and Node.js. It provides you with a visual modeling tool, which is your browser base. You need not download any IDE, and you can start sketching your applications right away. It is event-driven by design and provides support for AWS Lambda, that is your serverless architecture. It is 100% open source with zero lock-in. You can start using it and developing your applications right away as we speak. It also supports edge machine learning. We'll talk about all of this in detail. So when I say it's ultra light, right, how small it is. A traditional memory footprint for a Java application is around 180 MB. For a Node.js app, it's around 74 MB. With Flogo, the memory footprint is as low as 3 MB. And the best part is when you develop the apps to certain capabilities and deploy it on Edge, it also runs with applications with memory as low as 32 KB in size. Okay, so how did we get so small, right? Java and Node.js are great, we all love them, but they are simply too large for resource-constrained environments. So if you see here, the way these frameworks work is you have hardware followed by your operating system sitting on top of it, then you have your VM followed by framework libraries, and eventually you have your app running on this particular stacks. With Flogo, we are leveraging Golang, wherein all your dependencies are bundled together in one binary, which you can take and run it on your operating system of your choice. So you need not install or pre-install any of the prerequisite or runtimes. You just take your library, get the dependencies that you need, and go to the OS of your choice or edge of your choice and deploy it and run it. Okay. So how does a better IoT blueprint looks like, right? You have your devices, which is your point of action. Then you have your gateways, when your devices communicate with the gateways, and eventually the gateways communicate with the cloud. So you can bifurcate your logic, wherein some of your microservices can run on devices, some can run on gateway, and eventually, if needed, you can still leverage the computation power of cloud. So what are the benefits of this? You have more control. Since most of these devices are placed wherein there is no good connectivity, you can process or compute even when you are offline. You consume less bandwidth, and yes, definitely you take fewer hops to the cloud and you reduce the latency as well. Okay, this is how we have divided the framework. It's like event-driven by design, wherein an application is divided into triggers and actions. A trigger is nothing but which captures the event. It can be your MQTT trigger, it can be your REST trigger, and your activities collect events, process them, emit outputs for further processing. So it's a completely visual modeling tool or framework which you can leverage. So the best part about this is it also runs on microcontrollers, your Arduinos, wherein the footprint is very low, right? It can also run on ARM Intel OS systems. It's 100% open source, we talked about it, and it also supports statistical modeling. So this is a screenshot of how the web UI looks like. It's a low friction web native user interface wherein you can express your app logic, not just using data, but rich flows. You can perform some inline data transformations. There are certain set of functions available which you can reuse. It has a built-in web-based debugger wherein you can debug your app before deploying. And from the UI itself, you can build for target platform of your choice. There are multiple target platforms available. We'll talk about it in detail. So as a developer, all you need to focus on is building the logic of your application. That is step number one. Once you do that, debug your flows in the web UI, you can utilize the CLI or the CI/CD pipeline that you can create and deploy it. Basically, you have multiple options. You can deploy it into a Docker container. You can directly export AWS Lambda code and deploy it on your serverless environment, that is AWS Lambda. Or you can create a binary for your edge devices and run it on microcontrollers as well. So that step is the last step wherein your coding is completely bifurcated from your devices wherein you want to run the application. So what it also has is it also supports edge machine learning. So by default, the framework has the capability of executing TensorFlow models through the flow itself. So the framework or the app can collect the data, it can aggregate the data and pass it to the TensorFlow models wherein you can infer some logic. So why do you need machine learning at the edge, right? So with this terabytes of data coming in, if you go to the cloud every now and then, prediction is no more real time, right? We need real time prediction. So it needs to happen at the edge itself. You are saving massive data transfer by performing inference on the edge devices. And the last part is connectivity is no more a hurdle. You can even process or inference when your device is offline. So basically, you can inference on your devices, on your gateway, and if you still need to store and train your models, you can still go to the cloud and perform the functionalities out there. So I'll just summarize what is the value add of Project Flogo. A, you can build microservices faster than ever before with the web-based UI. It's easy to install. It's just a Docker container that you need to run a command, and you can start playing with it. It's available as an open source project, and the code is also available on GitHub. You can leverage the serverless platforms. You can develop the code for AWS Lambda and deploy it as well through the same logic. And the best part is you can deploy anywhere, including edge devices. That is your on-premise, cloud, hybrid cloud, or edge devices. And yes, it is extremely light, as we already discussed. So what next? We are continuously contributing to this open source project. So these are some of the features that we have on our roadmap. One is we are improving the modern lifecycle management, when you can control the lifecycle of models on running devices. Also push updated models remotely. We are also working on simplifying and sending asynchronously cloud metrics to your cloud devices so that you can utilize them to train your models in a better way. Secondly, we are adding support for other serverless platforms and also working on remote deployment to serverless platforms. And last but not the least, we are continuously working on the development experience by improving the number of activities and triggers that are available for the community, and wherein you can also help, and also improving the documentation around it. So what can you do next, right? I know it's afternoon, everyone wants to grab some beer, but what I'll suggest is you can please go to the flogo.io and do a Docker pud and start playing with this, give it a try. It's extremely easy, it's extremely intuitive. I'm sure you all will love it. You can also check out the code out here. So I will be here today and tomorrow as well. If you are working on any cool projects around IoT or have some ideas, then I'll be happy to chat with you guys as well. People who are online, these are my social media profiles. Please feel free to connect, and I'd be happy to chat. Thank you.
Thank you for your talk. We have 2 minutes left for questions. That should be 2 or 3 at least. So, yes?
Yes, please.
Just.
So with IoT, you have a lot of problems with issues like privacy,
Yeah.
encryption, security. How do you design that?
Yeah. So firstly, this one
Repeat
is,
the question, please, for the stream.
yeah. The question is more around how do you handle the security and privacy around IoT devices. But if you consider the framework, as of now, we are just focusing on building the applications around the IoT. But talking about the security and features as well, you can have all the encryption, like the MQTT trigger that we have, right? It provides all the encryption that's available with MQTT. So that way, currently the focus is more on developing around the application development rather than the other way around.
So, another minute left, another question. I don't see any hands, so I guess everybody will talk to you. Oh, there's one hand. Yes, please.
Yeah, please.
I didn't see any kind of benchmarks about the claim that it's about 50 times faster than Java and I don't know how many times
Yes.
faster than Node.js.
Yes.
How did you conclude that? How did you measure that?
So yeah, we have done some benchmarkings around running it on edge devices like Arduinos and all. So it is basically based on the memory footprint. We developed a similar app on with a similar functionality on all the platforms, and the benchmarking was done on that way. We have some details which, if you need, I can share with you as well.
Okay, so we have 10 seconds left.